Hello, welcome to our explanation on the comparator, and we continue explaining what comparators are. And specifically, we are going to compare the comparators with the operational amplifier used as a comparators. So remember, in our previous talk, we said operational amplifier can be configured as a comparator, and there are dedicated ICs used as a comparator. So there are fundamental differences when to use which IC. So to begin with, in this slide, we are going to understand what comparator is. So it's basically, you can see it compares the two input signal, V1 and V2, applied to its two terminal. Comparators, they are configured in an open loop configuration, always open loop configuration, as opposed to the operational amplifier, which operates in their linear modes of operation, linear region of operation. However, comparators operates in the saturation regions, where the output levels are either high or low. So comparators basically are designed to drive the digital logic circuits from their output. So this output, when it switches between the positive level or the negative level, or the high level or the low level, it is quite compatible to interface with the digital logic circuits and to drive the digital logic circuits. And the another characteristics of the comparator is to work at the high speed with minimal instability. So since these comparators internal structure do not require a Miller capacitor, which is usually the case with the operational amplifier, they are quite fast. They work at a higher bandwidth. So for example, you see here the working principle of the comparator. You have a amplifier. Essentially, any high gain amplifier can be configured as a comparator. So you see that you have an amplifier with a gain A. It has a positive input and the negative input. To the positive input, you have a triangular shaped waveform coming in. And for the negative input, you basically provide a reference. So comparator is always one input to the input and another input with the reference. Reference can be set to 0 volts as well. And to this reference voltage here is set by the combination of the resistor division circuit. You use the two resistors, one from the supply end and one is connected to the ground, and that's how you set up the reference voltage. So whether input is greater than or less than the reference, you have a switching between the two output levels at the output of this comparator. So you see here the reference voltage is a constant voltage set by VCC over 2, so half of the VCC. So if your VCC is 1 volt, your reference voltage is 0.5 volt. And now the input is a variation with respect to time. So you start with 0, your input is increasing, but it is as long as it is less than the DC voltage, reference voltage, the output is low. As soon as the input voltage is above the reference voltage, output is high. Again, the input falls below the reference voltage, the output is again low. So that's a basic working principle of the comparator. So you can see that from this output waveform, this is acting as a 1-bit A to D converter. So we can always also use the comparator and configure it as a 1-bit analog to digital converter. So you can see that here is a waveform. The red curve is an input signal that is varying with respect to time. And the middle one right here in the middle is a reference level. We say that above or below this reference setup, your input signal is varying with respect to time. So again, we apply the same principle to plot the output. If your input is above the reference level, output is connected, switch to the positive level, that is logic 1. If the reference voltage falls, below the reference, if the input voltage falls below the reference, output is switched to 0. And this cycle continues as long as the input signal is present. So this is the case when you turn an amplifier into a comparator circuit. You can definitely use amplifier, a high gain, any high gain amplifier, and turn it to use it as a comparator when you connect that, use that amplifier in an open loop. You don't use any feedback, and your amplifier will work as a simple comparator circuit. However, there are situations where input is noisy, so there could be a problem with the operational amplifier or any amplifier used, if used as an as a comparator. So the noise may cause a false switching between the states, that is logic 1 and logic 0. So to circumvent this issue where your precision is important, you have a dedicated comparator ICs where you use the comparator always in an open loop configuration, and you see that there are thresholds defined besides the reference voltage. So you have a center threshold as drawn over here, and you have lower threshold voltage LTH, you have upper threshold voltage UTH. So with this situation, you have, unless your input signal crosses the upper threshold or lower threshold, you don't have a switching of the output. So that helps to minimize the noise in the comparator output, and your signals are more precisely compared. So we will see ahead how the comparators solve this issue. So remember, comparators are used in high-speed applications, and comparators are also used when there is when there is a requirement of accuracy. Now, you see that the comparator uses is can be used for polarity identification. So whether you want to know if your input signal is positive or negative based on the output, you can understand what polarity of the input signal is. For example, if the output is logic 1, you say that the input is positive with respect to or with reference to the another input at the comparator, that is the reference. If the output is 0, you can say that the input voltage is negative and its polarity therefore is negative. As I said, the comparator can be used as a 1-bit analog to digital converter. So you basically can see that you have an input waveform and that is being converted to digital. So you always 1-bit data is coming there. You can use it for switch driving. You can use it as a square to triangular wave generation, like we are getting in the output as a square wave. We can also always generate a triangular wave. We can also have the pulse edge generation. So you also have the positive edge trigger or negative edge trigger pulses. So that was all about basic understanding of the comparator and its usage and its working principle, its output waveform. If you like this video, do share with others and stay tuned for more content on comparators, operational amplifier, analog electronics, and all major aspects of the electronics that is practiced in the industry. Wish you happy learning.